new problem. So this time we're going to look at a problem from economics of like kind of like supply, demand, cost, revenue, profit, and a kind of interesting economics point of view of selling stuff. Is if you take a look at the number of things you make, let's call that X things, and the price P you sell them at. If something is rare, there's not many of them, and people want them, right, then the price is going to be higher. If there's a ton of those things out there on the market, then stores are going to have them on the shelf. They want to get rid of them. They're going to drop the price to get rid of them. So often what happens is there's this downhill curve related to price and production of things. And so for simplicity, we're just going to let that be a straight line today. And so the price of, let's say, an electronic device P, we're going to let that be equal to negative 0.01, so negative 100th times X plus 400. So that's going to be the price. Now, so the price depends on how many things are out there in the market that we've produced. The revenue that we make, the simple version of revenue, it's just the price times the number of things that you sell. And so we have a price formula up there, so it's just going to be that negative 0.01 X plus 400 times X. And so our revenue is then going to be negative 0.01 X squared plus 400 X. Now, profit is the money that you make after you take away your costs. So if we look at cost here, so we can get to profit, let's say we know a formula for cost, and it's $100 per item, and there's a $10,000 like startup to get things moving, to get things built. So that's our cost. And then profit is just revenue minus cost. And so for us here, we're going to get that negative 0.01 X squared plus 400X. And then we're going to take away the 100X. And then it's going to be also take away that 10,000, because the whole thing has to be taken away. And if we clean that up, we're going to get negative 0.01 X squared plus 300X minus 10,000. And what we want to do is we want to calculate what's the rate of change when we're selling about we're making and selling about 10,000 items. Now, again, we're trying to find rate of change. We're only given a single number there, so we have to consider, well, rate of change involves 2 points, so we have to make up another point, and the standard way to do that is to say, well, let's just bump production by H. So maybe H could be 1 or 2 or a tenth. Now, this is kind of weird because you can't have a tenth of an electronic device. It's got to be a whole one or not, but we're going to ignore that fact for a moment. So then our other point is going to come from X plus H, right? And in this case, X is 10,000, so that's going to be 10,000 plus H. So then we look at the average rate of change formula. Which just says, okay, take your function, I'm going to call it capital P for profit of your X plus H, so that's my 10,000. Not to miss a 0 there. And then we subtract our profit at 10,000 units and we divide by H. So that gives us a rate of change. And then we'll just look to see what happens as H gets smaller is the goal here. So since this is kind of got some complicated numbers, I'm going to do it in stages. And my recommendation yesterday was stage 1 is to calculate that part of the function. Stage 2 is to then find the difference. Stage 3 is to divide, and then stage 4 is to let h go to 0 and see what happens. So first step here, P of parentheses is equal to negative 0.01 parentheses instead of an X. And I think I need a bigger parentheses there. And then it was what, plus 300 parentheses and then minus 10,000. Let me make sure I got that right. So this function here is my profit function. Good. Right. All right, and then we're going to drop in there the 1,000 plus h. So I got to write little tiny 10,000 plus h, 10,000. I got enough zeros, yep, plus h. Okay, so just got to do it out, see what happens. All right, so this part right here, remember, is you're multiplying it by itself, so that's really 10,000 plus h times 10,000 plus h. And then we'll distribute that negative 1/100th, probably after we do that. This one's pretty easy. We distribute the 300 in there, and what do we get? We get 3, 1, 2, and then 4 more zeros, 1, 2, 3, 4, and then we have to subtract 10,000 from that. Okay, and so distributing here, what do we get? We get 1, 2, 3, 4 zeros, and then another 1, 2, 3, 4 zeros, plus 2 of those, plus h squared. We still have to multiply that by negative 1/100th. So let's see here. We get, don't we still need to distribute the 300 to the h? Oh, shoot, thank you. I missed that part there. Oh, good call. Thanks, Kelsey. I was a little sloppy there. I forgot that part there. So what's that going to give me? Just a plus 300h. And then I've got that minus. I had my eye on subtracting these two and got distracted, or my brain was thinking ahead there. Okay, so let's see. So that's going to lose 2 of these zeros when we distribute here. I am going to distribute through. So what did we have? 8 zeros. We're going to lose 2 of them. So that's going to be 1, 2, 3, 4, 5, 6, plus, and then we'll lose 2 of those zeros, oops, minus. That's 200h minus 0.01 h squared. All right, so now we have to consolidate terms. 1, 2, 3, 4, 5, 6, right? And let's throw some commas in so we can keep track of them, and a calculator would be a really good thing here. So that's 3 million, and that's 1 million, so that helps a little bit. So let's see, we've got 3 million minus 1 million is 2 million, and then we're taking away 10,000. So those constants should leave us with what, 1,990,000? Someone check my arithmetic on that. 300 minus 200 is 100 h, and then that's just hanging negative 0.01 h squared. And the 100 is positive, and the 300 million dominated, so that's positive also. Oof, that was a lot of work. So there is part one. Then we have to plug in 10,000 here. So I think I'm going to whip out a calculator for that part. And I've been hooked on GeoGebra lately, but Desmos is lovely too. So I like to use function notation, so I'm going to call it P of x equals negative 0.01 x squared plus 300x plus 10,000, I think was our original profit function, minus 10,000. And I want to know what is P of 10,000. And oh, look at that. It's 100, let's see, 1,999,000. Well, that is lovely. That works out nice. So in red here, I just calculated that P of just 10,000 on its own. And I guess that makes sense, given that the 10,000 is part of that calculation up there. It's just 1,999,000. And we are subtracting this from that there. So that's going to kindly go away. So now we have our numerator. Whoa, it was supposed to be n. There we go. Numerator is the difference of those two. So that's just going to be this remaining part there. So negative 0.01 h squared plus 100 h. Okay, so we got step 1 done, we got step 2 done. The next step is step 3 to divide by h. So again, I'm calculating this version of the difference quotient. And here's where we're at. Was that 200h? Yep, no, 300 minus 200 is 100h. All divided by h. And this right here is the formula for our average rate of change given some small change in production, which is h. And so the h's kindly divide out partially. So I'm left with negative 0.01 h plus 100. And so this right here is our average rate of change. Average rate of change between x equals 10,000 and x equals 10,000 plus h. So if we say production went up by 1 unit, then we would see that the rate of change of profit would be 100 minus that value right there. So if we then take the limit as h goes to 0 of that, then this term right here becomes more and more negligible, and the pattern should be that we should see, well, it looks like the slope there is about 100. And 100 what? Okay, so the numerator is profit. The denominator is X, the things we're producing. So this would be dollars per thing produced is what we have there. Now this is positive, right? So that's something to know. There's a positive slope here. Positive change in production. Meaning that if we start producing more than 10,000 things per year, then we're going to see more profit than we did before. So profit is increasing at this stage in production. And we can look at the graph to see that that's the case. So if we produce more than 10,000 things, a little bit more than 10,000 things, we should find we're making more profit than we were when we're producing 10,000 things. And so that's good to know. So let's go back here. Notice the Y value here is 2 million, so I should change my axes. So there's a couple ways to do that. I'm going to go into settings here, and Desmos has a similar thing. X value was 10,000, so maybe I'll bump the max up to, I don't know, 50,000. And then the profit was, at that point, almost 2 million, so maybe I'll jump up to 3 million and see what it looks like. 1, 2, 3, 4, 5, 6. Ah, look at that, beautiful, I got lucky there. So here's our profit curve right there, and we were considering the points, 10,000, comma, P of 10,000. So there's that point right there. And we found the slope at that point. So if you want to do a tangent line, the quick way to do a tangent line, if you wanted to see that rate of change as a line, the easiest way to go about that is to use the point slope formula, which is y minus y1 equals the slope times parentheses x minus x1. So let's take a look at that. So I can just type that pretty much as I see it, y minus, and I'm just going to call it P of 10,000 is my y value, equals the slope, which we found to be, what was it again? 100 times parentheses x minus 10, 1, 2, 3. Bang, look at that. We nailed the slope there. Interesting thing, the rate of change of profit, if we slide that point up a little bit, it's going to be, the slope is going to be more shallow, right? We're kind of steep right here, but as we walk toward the peak, it's going to get shallower and shallower and shallower. On the other side of the peak, right, let's suppose we were doing not 10,000, but maybe 20,000 units. So let's say our boss hears, hey, you could produce more and you'll make more money. That's true to a point. At the top here, things start to change. So if I made that 10,000 a 20,000, I got to recalculate the whole thing for that. Okay, can't easily show that here, can I? But we can imagine it. So I'll just plot the other point. So if I do 20, 1, 2, 3, comma, P of 20, 1, 2, 3, the slope on this side would be negative. And so if we were producing 20,000 things a year, then what we would find is we'd be losing, we'd start to lose profit. Now we're still profitable, right? We're still making almost $2 million a year on those 20,000 things, but our profit is decreasing at that point right there if we change production. So increasing change in profit, decreasing change in profit. And often in economics, that's called marginal profit. All right, oof, that was exciting.